Good morning students. In today's video, I am going to share about the CPU scheduling in the operating system. CPU scheduling, it is the process and which is used by the operating system to decide which tasks are processed to get to use the CPU at a particular time. Because in a CPU at a time, any one task or process that can be executed at a particular time. So this is important because the CPU can only execute one task at a time. So but there are usually many tasks that need to be processed. So there are the need of the CPU schedulings are: one is fairness, efficiency and responsiveness. Fairness, it ensures that each process receive a fair share of CPU time, which means the process that they are entering in the new queue that will be in the order. In the same order, CPU that executes the process. And efficiency, it maximizes the CPU utilization by minimizing the idle time or waiting time. And responsiveness, it provides the timely responses to the interactive process so that it improves the user experience. So CPU scheduling is the process of decides which process will want the CPU to use while another process is suspended. So the main function of the CPU scheduling is to ensure the whenever the CPU remains idle, the OS has to at least selected one of the process available in the ready to use line. There are several CPU scheduling algorithms are there. The first one is FCFS, second one is SJF and priority scheduling, and the last one is round robin scheduling. Here when we talk about the FCFS scheduling, it is the first and most or simplest scheduling algorithm than others. So it is easy to understand and it can be easily we can maintain it, implement it. And the fairness, it ensures the process are executed in the order they arrive. And convo effect, which means a long running process at the front of the queue can block other process because the process that will enter in the order they arrive. So that if that, for example, if the process 1, if if it takes too much time to execute in the CPU till that other process in the ready queue, it has to wait. So it blocks that. So process P1 block other process time. So it is the convo effect. So it is the simplest type. And FCFS scheduling is the non-preemptive algorithm, which means once a process starts the execution, it cannot be stopped until voluntarily. So when it terminates or performs IO. So this method treats all the process equally without any priority. So the FCFS functionality is the mechanics of FCFS are straightforward. It has three steps to execute the FCFS scheduling. One is arrival, execution and repeat. In the arrival, process enter in the system and are placed in the queue in the order they arrive. And execution, the CPU takes the first process from the front of the queue and executes it until it's complete and remove it from the queue. And repeat, the CPU takes the next process in the queue and repeat the execution process. So it continues until there are no more process left in the queue. So CPU scheduling is the non-preemptive scheduling algorithm. So that once a process starts running, it cannot be stopped. So the terminologies of FCFS schedulings are: first one is arrival time, burst time, completion time, and turnaround time, waiting time. So the arrival time, in our arrival time, that it is the time at which the process arrives in the ready queue. So it can be represented as AT. Burst time, the time required by the process for CPU execution is burst time, and it can be represented as BT in a short form. And completion time, the time at which the process completes its execution is known as the completion time. It can be represented as CT. And turnaround time, it is the difference between the completion time and arrival time. So it can be calculated using the formula CT minus AT, which means completion time minus arrival time. In a waiting time, the time the process has been waiting to complete its process, which means it can be calculated using the formula turnaround time minus burst time. So for example, here I have taken 5 processes P1, P2, P3, P4, P5, and for these 5 process ID is allocated. So OS allocates the process ID for every process that they are entering in the queue. So P1, the first process is named as P1 and followed by P2, P3, P4, P5. So 5 processes are named as P1 to P5, and the arrival time and the burst times are given for every process P1 to P5. So for the P1, the arrival time is 0 and burst time is 6. So P2, arrival time is 2 and burst time is 2. For the P3, arrival time is 3, burst time is 1. For P4, arrival time is 4 and burst time is 9. For P5, arrival time is 5 and burst time is 8. In the Gantt chart, we have placed the 5 process. So in the order, the CPU will execute this process. So the process P1, P2, P3, P4, P5. So first we have to place the P1. So P1, for the P1, the arrival time is 0. So initially we have put 0 in that box. After completing the process P1, we have to mark 6 because the 6 is the burst time for P1. Then for the 6 is the arrival time of P2. So the completion time of P2 is 2. So 6 plus 2, which is 8. So 8 is the completion time of process P2. So the 8 is the arrival time for P3. So the burst time of P3 is 1. So 8 plus 1, 9. So 9 is the completion time of process P3. So this completion time is the arrival time of process P4. So that burst time of P4 is 9. So 9 plus 9, 18. So 18 is the completion time of process P4. So this 18 is the arrival time of the last process, which is P5. Here the arrival time of process P5 is 8. So 18 plus 8, that is equal to 26. This is the completion time of process P5. So here in this table, already we have given arrival time and burst time, and also we have calculated the completion time. With these 3 time, I have calculated the TAT and the WT, which means turnaround time and waiting time. Already we know the formula for calculating the turnaround time, which is TAT equal to CT minus AT. Using this formula, I have calculated the turnaround time 6, 6, 6, 12, 21 for the 5 process. Like this, I have calculated the waiting time for 5 process. And finally, we have to calculate the average completion time for all the process. So here I have got 13.4 is the average completion time of the FCF scheduling. So finally, the advantages of the FCF scheduling is it is a simple and basic form of CPU scheduling algorithm. It can be implemented easily and it does not require any complex data structure, and every process gets a chance to execute in the order of its arrival, and these processes are executed in the order they arrive, so there is no risk of starvation, and it is well suited for the batch systems. And finally, the disadvantages of FCF scheduling it is a non-preemptive CPU scheduling algorithm. So the average waiting time in the CPU is much higher than in the other scheduling algorithm, and processes that are at the end of the queue have to wait longer to finish. So it is not suitable for the time sharing operating system, where each process should get the same amount of CPU time. So in the next that's all about the FCFS scheduling. In the next video I'll show you what is SJF scheduling, and how it will be run in the CPU. In the next class we'll meet you. Thank you.